All right, another skill that you're going to need to be able to do is to simplify something like what I've highlighted up above. Oh boy, there's a lot going on here. Well, the first thing you're going to do is simplify it like this. So on top, you can rewrite that as 4i. On the bottom, we've been combining like terms a lot. You can combine real numbers to get -2 and imaginary values to get, there's a 1 in front of this I, there's one I there, and there's two I's over there, so that makes positive 3 I's. Ooh, I'll rewrite that. So that's where we're sitting. By the way, these other ones in this set that you see look exactly like where I'm sitting at right now. So you'll have to know, all right, I can rewrite the square root of a negative number as that number with an I. Oops, and we should have a negative, just kidding, just that number with an I. And then also to combine like terms on the bottom to get a binomial like you see right here. But this is still not simplified because we never should have an imaginary number in the denominator. We can have one on the top, the numerator, but not the denominator. And this is where we've practiced getting the conjugate. So what's the conjugate of what I have highlighted in green? It's going to be -2. You just copy the first term, but you take the opposite of the imaginary value. So instead of a positive 3i, it's going to be a negative 3i. Now remember, when you multiply the bottom of a fraction by something, you have to do the exact same thing on the top. And now we just simplify. And I wish I would have given myself a lot more space. So I'm going to highlight the top in blue. So our new top is going to be, when you distribute the 4i through, you get -8i and -12i squared. But remember, when you get an I squared, it's really like a -1. So really, this is like, thought bubble, -12 times -1, which is positive 12. So I'm going to put a big, bold positive 12 over this. Positive 12, getting rid of the -12i squared. On the bottom of my fraction, what will I have? Well, you need to FOIL or multiply this out. So we get you might need to use scratch paper on this, folks, because this takes some room. I didn't provide that on your PDF. I apologize. Ooh, and we should put parentheses around here. We are FOILing this out. This -2 gets multiplied to everything over there. So we get positive 4 and positive, because we have a -2 times a -3i, a positive 6i. And then over here, we've got 3i times -2, which is -6i. And over here, -9i squared. Wait a minute, say what? -9i squared? This whole thing right here becomes a positive 9 because it's really -9 times -1, which is positive 9. So let's simplify what we have here. We've got on top a positive 12. I'm going to put that first because it's a real part. And then I have this imaginary part of -8i. That's the better way to write it. On the bottom, I've got 4 and I've got 9. That's 13. And then I should have written that better because I know what's going to happen. Check this out. This is why we got the conjugate, folks. As long as you get the conjugate correctly and do your distribution correctly, this should happen on the bottom. You get 6i and -6i, and that becomes 0i. That cancels out. So on the bottom, all you have is 13. I'm going to write it nice and neat in the center. 13. And there we are. That is a simplified answer. Now, if you could reduce all 3 terms by something, do that, please. But I don't think that'll come up. I kind of hope it doesn't. So that is your process. Again, to recap, this is the same as 4i. This, we combine like terms to get to there, what's in space. To give you a little backstory on these, I wasn't able to cook them up the way number 43 was, but you need to be prepared for one like 43. So it might start with the square root of negative 10 on top, which you can't do. But you can turn it into 10i. And the bottom might have something like negative 10 plus 2i plus 4 plus 5i. Well, that part you just put together to get negative 6 plus 7i. So really you have to do 2 little steps, or be willing to do 2 little steps, but the hardest part is moving on from there, and that's what this practice is going to have. But put in your notes so you can be prepared for what I have in yellow as your first step, or number 43, the way we did that first step. So your next move, you cannot have i's on the bottom. So we're going to take this whole thing on the bottom and multiply it by the conjugate. The first term stays the same. The real number stays exactly the same. But the imaginary goes to the opposite. So this positive 7i that we're given becomes a negative 7i. What do you multiply the top by? Exactly what you multiply the bottom by. Otherwise, this is no longer equivalent, and you're messing with the problem in a bad way that won't get you the right answer. Got to keep things equal as you solve equations. Or expressions, for that matter. All right, so here we go. So we distribute. On the top, we get negative 60i. Oh, sorry, negative 60. Yeah, that's an I. Negative 60i. And negative 70i squared. Remember, this negative 70 really becomes a positive 70. So I'm going to put plus 70 because it's negative 70 times negative 1. On the bottom, we get 36, 42i, and then distribute the negative 7 through, you get negative 42i and negative 49i squared. I'm going to move a little farther from the TV. I've got, I don't know, some sort of cartoon in the background. Childcare. $12 a month. Just kidding. Most of the time we do other stuff. But, alrighty. So, let's simplify the bottom. On the bottom, well, when we combine the i's, check that out. 42i and negative 42i become 0i or no i's. Coincidence? No. Using the conjugate creates that. And then there, that's negative 49 times negative 1, which is positive 49. Essentially, you're always just taking the opposite of whatever symbol's in front of the I squared term. See that? So now on the bottom, we can combine 36 and 49, which equals 85, if I'm not mistaken. And on top, let's put our real term first. Our real term is 70, and our imaginary term is negative 60i. Now here's a situation where you can actually take all 3 of the terms and divide them by something. What number goes into all 3 of these terms? 5. So I'm going to divide everything by 5. And so I get 14 minus 12i over 17. That's a better answer. Bada bing, bada boom. Let's try number 48. Again, number 48 would have started with something like negative, the square root of negative 2, which is 2i. And then on the bottom, you combine some stuff to get that. Moving forward, the bottom has an I in it. We cannot do that. So take the bottom and multiply it by the conjugate. First term, the real term, stays exactly the same. The imaginary term goes to the opposite. So a negative 2i to a positive 2i. What you do on the bottom, got to do on the top. Beautiful. Distribute. Negative 8i. That looks messy. Negative 8i plus 4i squared. And then over here, we get 16 negative 8i. This would get you positive 8i. Yes, again, you should get opposite I terms in the middle there. If you didn't, something's goofed up. Either your conjugate or you didn't multiply correctly. Negative 4i squared at the end. So, oh geez, I forgot to realize, holy cow. This is an I squared term, so it's really, ooh, I shouldn't have circled it that way. This is a positive 4i squared. It goes to a negative 4. This is a negative 4i squared. Goes to a positive 4. Now when you do that, yeah, don't lose sight. Like I crossed this thing off. Make sure you actually see what you replaced it with or rewrite it as a whole new step. I don't know. Just keep track of your stuff. And then on the top, write your real number first. The real number is negative 4. The imaginary number is negative 8i. On the bottom, your i's cancel out. You have 16. Now that minus sign right here goes with the 8i, right? It's a negative 8i. So, you have positive 16 and positive 4, which is 20. Now you can divide all of these numbers by 4. 4 is the greatest common factor. So then you get negative 2 minus, whoa, that's not right, just kidding. Negative 4 divided by 4 is negative 1. Minus 2i divided by 5. That is the better answer, or the best answer. Sweet.